Welcome to day 3 of vectors. Today we're going to talk about a particular type of vectors called unit vectors. To talk about a unit vector means that we have to understand what a unit vector is first. Very simply stated, a unit vector has a magnitude or length of 1. In order to figure out a unit vector in the same direction as an existing vector, we divide the existing vector by its magnitude, and that produces a unit vector in the direction of the existing vector. So here we have an example. We have vector v with component form -2, 5, and they want a unit vector in the direction of v. So the first thing they're going to do, Pythagorean theorem, to get the magnitude. They're going to divide that vector, the -2, 5, each component by that magnitude, and that is your unit vector. Now they're going to verify that the magnitude of this vector is 1 by applying the Pythagorean theorem to it. And when they square both of those pieces, add them together and take the square root, they verify that the magnitude is 1. We have a couple of unit vectors that we consider to be standard unit vectors, and they're labeled I and j. I is the horizontal vector, you can see here, goes along the horizontal axis. J is the vertical vector, and it has the component form that you see here, the 1, 0 for I and the 0, 1 for j. These vectors can be used to represent any vector as a linear combination. So we can take a vector v that has a horizontal v sub 1 and multiply it by I, because that is the horizontal unit vector, and take the vertical component v sub 2, multiply it by j. So we can do what we call, I'm going to write this over here, a linear combination of I and j. And there's the notes on that. Now, direction angles can also be written as a vector. If you look at the triangle inside this circle, you can see that we have the x being the cosine of theta, the y being the sine of theta, and we can write cosine theta I plus sine theta j, where theta is the direction angle of the vector. So in doing this, we've derived a little formula that helps us come up with the component form of a vector using its theta and its magnitude. The magnitude times cosine theta and the magnitude times sine theta. Here we have used that to get back to the direction angle, which we talked about a couple of class periods ago. So if we want to find the direction angle of a vector, this is our x, this is our y. They're calling it B and A. I still like the idea of calling it y over x, which gives you 3 over 3, which is 1. And in the first quadrant, that's 45 degrees, or pi over 4. For letter B, we have a 3 and a negative 4. Now that doesn't match anything on our unit circle. So we would need to use the calculator for that. And because that's in quadrant 4, remember that we're going to add 360 to that. And that'll give us the 306.87. Now, in looking at some applications, this is one example of a word problem where we're asked to find the component form. So we have the magnitude. We'll just call this V is 150. And it says that the angle is 20 degrees below the horizontal. Well, this angle looks like it's in the third quadrant. Yep. So if it's in the third quadrant and it's 20 degrees below the horizontal, this is 180. So 20 more degrees is 200. And what we're going to do is we're going to use that little formula that we derived, magnitude times cosine of theta, magnitude times sine of theta, and we'll get our component form from that formula. And you can double check once you get that component form, you can apply the Pythagorean theorem and make sure that the magnitude matches up to what you started with. That's just one of many applications. I'm sure you guys would consider them to be word problems, but just one of many applications.